Hello and welcome to this online College of Coding video tutorial series. This is video 3 in the series of intermediate breaky blocks in Unity. In this video, we'll be creating the ball that will bounce against the paddle and the walls. Before watching this video, it's recommended you've seen the previous videos in the series, as well as the Introduction to Unity and Intermediate Programming Concepts videos. Alright, let's get started. We've got a moving paddle in our game, and it's confined within some walls, but there's no action just yet. We need to import the relevant assets so that we can create a ball game object with all the right components that will let it bounce around inside our walls. To do this, we need to import the ball asset package. Just the same as the paddle asset package, the ball only contains one image, so just click import. That image, just like the paddle image, has gone into the textures folder in the project browser. To begin creating the ball, in the hierarchy we need to create a new 3D object. We want a quad, and then we can drag the ball image onto that quad. By pressing F, we can zoom in on the ball, and then to fix up the image, we can change the shader to unlit transparent. Now let's use the inspector to change the name from quad to ball. Within the transform component, we need to set the scale on the x-axis to 0.3 and on the y-axis 0.3 also. You can leave the z-axis at 1. This is just so that in relation to the paddle, the ball is a sensible size. Next in the inspector, find the mesh collider component and remove it. While we do need a collider on the ball, we don't want specifically a mesh collider. We're going to use the add component button to add a physics 2D circle collider to our ball and set its radius to be 0.45. If you zoom in once more, you can see that 0.45 is a nice tight fit around the ball. Let's use the add component button again, and this time we're going to add a physics 2D rigid body. Because our ball will be moving in the game, a collider component alone isn't enough to detect collisions. We need to add our ball to the physics engine by giving it a rigid body. In the rigid body, we're going to set the gravity scale to 0, then set the sleeping mode to never sleep and the collision detection to continuous. Never sleep will mean that our ball is constantly checking for collisions, and continuous will mean that each frame when it moves a distance, it'll check for a collision between where it was and where it is now, just in case it moves past an object. Next, go to the Assets folder in the project browser and right click. We need to create a new folder. We're going to call this folder Prefabs because we need to make the ball into a prefab now. So drag the ball object from the hierarchy into the Prefabs folder. Now that we have a prefab of our ball object, we can delete the original ball from the hierarchy. With the prefab selected, go into the inspector, click the add component button and scroll down to new script. Name the script ball, make sure the language is C#, then click create and add. If you go to the assets folder, you'll find the ball script, drag that into the scripts folder, then double click on it to open it in MonoDevelop, and we're going to add the code that will give the functionality to our ball. In the new class we've created for the ball object, we remove the top line or function head from the update function and replace it with a new head that gives us a function called launch. By replacing the function's head, we can reuse the brackets and anything else inside the old function body. The float variable speed will control the speed that the ball travels within the game. The launch function is a public function so that it can be called from the paddle script. When called, it'll separate our ball from the paddle and give it a velocity to start it moving. Next, we need to add some code to the paddle script. So double click the paddle script and open it in MonoDevelop. In our paddle script, we have to add a few variables so that it has the capacity to deal with the ball. For instance, the paddle will be in charge of creating the ball when the game starts, so it needs to know about the ball prefab, and it'll also keep track of the instance of the ball that it's created in the game. Because the paddle's going to be creating the ball, it'll need to know the position to create it at. This transform data is stored within the ball location variable, and the actual transform that the data comes from is what we're going to create next when we return to Unity. The start function is going to instantiate the ball, then attach it to the paddle as a child game object. And lastly, the start function invokes another function called launchBall to be called after 3 seconds. The launchBall function simply calls the function launch from the ball script. So now, right-click the paddle in the hierarchy and click Create Empty. Now we're going to use the inspector to name the empty game object ball spawn location. Set the position of ball spawn location to 0 on the x-axis, 0.8 on the y-axis, and 0 on the z-axis. This puts it just above the paddle where the ball is going to be spawned. If you click on the paddle and press F, Then select the ball spawn location. This circle here is going to be the center of the ball. Now select the paddle in the hierarchy and drag the ball spawn location object into the script as the ball location. We next need to go to the prefabs folder and drag the ball prefab into the ball prefab variable within the paddle script. Now if you press play, paddle should be attached to the ball, and after 3 seconds, it'll launch. The only problem is when it collides with the roof, it stops moving. In order to make our ball bounce, we need to apply a physics material. A physics material will determine how an object behaves in a physical interaction. For example, in a collision, we can use a physics material to make a particular object more or less bouncy. In the Assets folder of the project browser, right-click, then go to the Create menu, and create a new Physics 2D material. Name the material Bouncy, then use the inspector to set the friction to 0 and the bounciness to 1. Now go to the Prefabs folder, select the ball prefab, and if you go back to the Assets folder, you can drag the bouncy material into the Physics material slot of the Circle Collider 2D component. Now we can press play, and our ball should bounce off the roof, but not off our paddle just yet. To make our ball bounce off the paddle, we need to select the paddle in the hierarchy, and then use the inspector, and in the inspector, click the Add Component button and add a Physics 2D Box Collider 2D component. Tick the Is Trigger box, then set the offset to be 0 on the x-axis and 0.35 on the y-axis. See, that's moved our box up, and in the size, leave x to be 1 and y to be 0.3. And now we've got a collider component that is just the top of the paddle, the part that the ball is allowed to collide with. Because it's bad practice to have a moving object with a collider component and no rigid body, we need to add a rigid body to our paddle. Doing this passes the complex collision calculations onto the physics engine and eases the load on Unity, which in turn makes our collision detection drastically more accurate and reliable. So add a Physics 2D rigid body and set the gravity scale to 0 and set the body type to kinematic. So our paddle's not going to feel the effects of gravity, and by making it kinematic, it'll only move when we tell it to. It won't move if it gets bumped into or anything like that. Now that the paddle's set up to be able to bounce the ball away, we need to tell the ball how to bounce. So go to the scripts folder and open the ball script in MonoDevelop, and we're going to add just a bit more code. The new code in our ball script is going to calculate the angle that the ball follows when bouncing off the paddle. The value specified in the refraction multiplier variable will influence the angle of the refraction of the ball. The range property above the refraction multiplier will show a slider bar in the inspector instead of a raw number value. You can use this property to restrict the range of values that a variable can have. To detect the collision with the paddle, we're going to use the onTriggerEnter function. So when the ball enters a trigger volume, it checks to see if the trigger volume belongs to the paddle. When it is a ball and paddle collision, we reset the ball's velocity on the x-axis to a value that reflects the distance it is away from the center of the paddle, multiplied by the refraction multiplier. That might sound like a whole lot of maths and science jargon, but what we're doing is when the ball hits the paddle, it's going to bounce away. And instead of bouncing away perfectly, we're creating our own angle that it's going to bounce at. And that's going to be a larger angle if the ball hits the outside of the paddle than if it hits in the middle of the paddle. Now once the ball bounces off the paddle, and again off the roof, it'll bounce back off the paddle. If you're careful enough to bounce the ball on the edge of the paddle, you'll see that it bounces away at an angle. Then you can pause your game, and if you want to have a play around, click on the ball in your hierarchy, go to its script and drag this refraction multiplier right up, unpause it, and see that the angle gets bigger. But if you bounce it in the middle of the paddle, it's just going to bounce straight up. The ball is now complete, and so is this tutorial. Well done. Stay tuned because I will see you in the next one.